Go, live at the palace. All right, let me go ahead and fill in the unit circle from where we left off yesterday, and let's just see if you guys can kind of just visualize and practice this mentally here. So here was plus plus, and that'd be the first thing that I do on the quiz tomorrow. This will be minus plus, and see if I'm good. Minus minus, and this will be plus minus. Okay, we good there? Those are the SIG ends of the quadrants. Okay, then we're going to count the unit circle out. So this would be 0 degrees, and if you leave off degree marks, I counted off today for anybody that left off the degree marks. So when they put 120, if they didn't have the degree, it was wrong. Okay, and I had kids that missed degree marks. I know, I have this problem. All right, because I want to teach you to pay attention to detail. This is 30, this is 45, this was 60, this was 90. I can count by 30s and 45s at the same time, and I bet most of you can. 90s, this is 120, this is 135, this is 150, this was 180. I'm better at the radians. This is 210, this is 225, this was 240, this was 270, this was 300, this was 315, this was 330, and this was 360. This is 0 rad. All right, this was pi over 6, and I will skip, I won't count radians both at the same time. We'll just do the pi over 6s, because this is probably the part that some of you will have a hard time with, so I'll review this. This is 1 pi over 6, we skip the 45s when we're counting by pi over 6. This would be 2 pi over 6, which is pi over what? And if you remember, I told you yesterday, if you're 60 degrees away, and I'm going to teach you the ways of the force tomorrow, I'm going to teach you to use the unit circle. And we're going to do literally 100 problems, and your goal is to be able to get good enough to where you can do 100 problems within 20 minutes. Where you can just look at it and say, tangent of 7 pi over 6, boom, got it, answer. Okay? And then you just do it, all right? Got to be that good. You got to be that quick, okay? You will be. Every year I get everybody that good. In fact, most people get faster than me. Okay? I will say, all right, class, what's tangent of pi over 3? And they've already got the answer, and I'm sitting there thinking, oh, tangent of pi over 3, what is the answer? And then I have to sit there and think about it for a while. So you'll get better than me, even though I know the answers are 3. But that took me like 15 seconds to do. All right. So 1 pi over 6, 2 pi over 6. 3 pi over 6 is what? Pi over 2. I will say this on a side note here, this is a tangent, but every kid I've ever had take my calculus said, they say two of the most beneficial things, besides learning to work hard and doing a lot of practice, because the second, third try is where you're going to feel like, oh my gosh, this is like college course on crack, okay? But the two things they always say, besides that has been helpful to them, they say when they go to college, they cannot believe they sit in class and they have to tutor everybody on the unit circle. They feel like I'm the only one that knows how to teach a unit circle because they go to college and nobody knows how to do the unit circle. And the second thing is the common graphs. I don't know how many people have came back and said, man, that makes college math so much easier. Because when you know the graphs, because there's a lot of college professors out there, you're going to get some old school teachers that say, you know those graphing calculators you got? Put those away. We don't use those in my class. Because they're old school math teachers. And they're going to say, I don't believe in graphing calculators. You got to do everything by hand. Don't be surprised. I won't be surprised if at least half of you run into one of those teachers at least once in your college career, if you take some math. Okay? If you don't take a lot of math and you're good, then hopefully you'll be done after this class. Okay? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 is what?
2 pi.
2 pi over 3. All right? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This is 5 pi over 6. This was 6 pi over 6, which is pi. This is 7 pi over 6. This is 8 pi over 6, which is 4 pi over 3. This is 9 pi over 6, which is 3 pi over 2. This is 10 pi over 6, which is 5 pi over 3. This is 11 pi over 6. I told you I was better at radians. And this is 2 pi. I like radians way better than I like degrees. Okay? And you will like it too. The pi over 4s are the easiest ones because they're just going to be the what?
They don't.
You just hit the middle, but what are they going to be? Just odd integers. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Are we done? Was this where we were at yesterday? All right, let's fill in the rest of this beautiful thing. Now yesterday we got to the point where we understood in the unit circle that x is equal to cosine and y is equal to sine. That is so huge because that's going to be the key to understanding everything that we're going to do tomorrow. Because the three things that we're going to do tomorrow with unit circles: one, understand how to locate an angle where it terminates, which we did the other day on the trig basics. Okay, where you just figure out where the angle finishes, where it terminates, quadrant 1, 2, 3, or 4. Then you're going to have to figure out reference angle, and knowing where it terminates and its reference angle, you'll be able to use that idea that x is cosine, y is sine to figure out what the sine of 11 pi over 6 is real quick in your head, or sine of 23 pi over 6, or sine of 45 pi over 6, or whatever it is, okay? Or tangent of negative 5 pi over 3. You'll be able to do those real quick, okay? So, x is cosine, sine is y. Now, I'm going to show you quadrant 1, and I want to convince you today that learning this unit circle is as easy as 1, 2, 3. But I want to prove it first, and the only reason I'm doing this is because some of you are taking the ACT soon and need a review of 30, 60, 90, and 45. We'll start with 30, 60, 90. How about that? How many of you remember your 30, 60, 90 rules from Ratner's class?
Yeah.
Okay? So if you do remember them, great. If you don't worry, I'm going to review them. 30, 60, 90. We're going to start with the first ordered pair. Now remember, we're only learning the multiples of 30 and 45. And 60 if you want to say 60, but 30 catches the 60. So we're going to learn the multiples of 30 and 45. Those are the only angles you're required to memorize cosine and sine values for. There's nothing else in mathematics, and I have a master in my master's degree in mathematics, and I was only ever required to memorize the 30s and 60s and 90s. You won't have to go beyond that, trust me. So once you learn these, you know everything you need to know as far as memorization for sine and cosine values. If it's beyond that, you'll always use your calculator, every time. Okay? So we're going to memorize what cosine of 30 is. We're going to memorize what sine of 30 is. We're going to memorize what cosine of 315 is, what sine of 315 is. And we're going to memorize it by learning the unit circle. So when I find this point here, what I want you to remember is that the x value is the cosine value. Cosine of what? That 30-degree angle. The y value is the sine of that 30-degree angle. So whatever these two coordinates are, you've just memorized the cosine and sine value. So let's look at this first triangle. We know that it has a reference angle of 30 degrees. Would you guys agree with that? And I can create a reference triangle. Don't draw on your unit circle. Just let me draw on mine. And can I erase all these angle measurements? Are you okay with that? Good, because I won't room. This is 30. Drop my altitude straight down. Now we got a 90. This is x, this is y, this is r. I want to figure out the xy value. I know in the unit circle, r is what though? 1. That's huge. So now I'm going to draw this triangle out here. And this is where you want to write down some review stuff. This is x, this is y, this is r. This was the 30. So if that angle down here is 30, location is everything. If this one is 30, what's this one? 60. Now, r is the hypotenuse. Remember, it's high and mighty. It's always going to be the hypotenuse. It's actually the longest side, but we don't call it the long side. Does anybody know which one we call the long side from our review of geometry? The one opposite 60. This is what you call the long side, or the long leg. Does anybody know what the one called opposite 30 is? That's the short leg. And that's the basis of your rules. All right, let me review the rules for you. 30, 60, 90 rules are this. Hypotenuse, write this down. It's 2 times short. If you're taking the ACT, this will help. Long leg was what? Do you remember the relationship of the long leg and the short leg?
Is this for 30?
No, wait, no,
Is this for 30 or 60?
30, 60, 90.
Yeah.
But we're doing the 30-degree angle first. Yeah, good question. What was the long leg relationship? Root 3. It was short leg times root 3. And I always put the short first because I like the number in front of the root. That's what I memorized. That's what I have memorized. Some people are like, you know, I memorize them with variables. Why would you do that? I want description. Hypotenuse is 2 times the short. Long leg is short times root 3. So the long leg is always root 3 bigger than the short leg. The hypotenuse is always 2 times longer than the short leg. That is the relationship in a 30, 60, 90. That was discovered. That was when they started observing 30, 60, 90s, and that's the relationship that always came up. That the long leg was always going to be root 3 times the short. The hypotenuse was always going to be double the short leg. It always happens that way. So if that's the case, The long leg is x, the short leg is y. Let's see if we can figure out what x and y are. R. Anyway, hypotenuse is which one? R, which we know is what? 1. So we're going to do, let's do this one first. 1 equals 2 times the short. Which one's the short? Y. So when I solve for y, what are you going to get y to be? 1/2. There you go, first coordinate. Let's write it in there. That means y is 1/2, which we know. Now this is the power of what you just did. You just figured out what the sine of 30 degrees is. Because remember, I told you the y value in the unit circle is the sine of your angle theta. If you don't believe me, take your calculator out right now and go sine of 30 degrees and you will get 0.5. I promise you. You want to verify that yourself. Let's go to the cosine value. I do want you to do the cosine one because I don't think people believe me on this one. All right, if we've got the short leg now, this is 1/2. How do we find the long leg? Long leg. How do we find the long leg?
Short times root 3.
All right, the long leg is x. It's going to be x equals the short leg, which is 1/2 times root 3. So what do we get for the short leg? Or sorry, the long leg? We get root 3/2. So that is the x value for that coordinate. Now take out your calculator. Just humor me one time today. Just one time. Okay? Take out your calculator. Because I do need you to see this because your calculator doesn't give you root 3/2. Okay? And I hate to tell you, they don't have a TI-84 Plus that'll do roots like this. Okay? They have a TI-89 that'll do it. If you want to buy the TI-89, it does do roots for you. It simplifies roots. Okay, TI-84 doesn't simplify roots. TI-89 also simplifies with pi. TI-84 doesn't. It'd be nice if it did. With your calculator in degrees, so I think that'll be more handy. Let's type in cosine of 30 degrees. And tell me what you get. 0.86. How can I verify that that's really root 3/2? Let's just figure out what root 3/2 is. Go root 3 divided by 2. Well, this is practice drives. Well, you got to go root 3.
Same thing.
Well, see, that's why we drive. What'd you get for root 3/2?
0.86.
0.86. Now, one more thing that I want you to do. I say this also works for radians. But to do it in radians, what is 30 degrees in radians? Well, you got to know this. 5 or 6. Okay? Change your calculator into what to do this? Radians. Go ahead. Change your calculator back into radians. Now go cosine of pi over 6. It should give you the point what? Better give you the 0.86.
Yep.
Does it? All right, so we verified it. So you've humored me enough today. Does everybody get it? Now we're going to start cheating the rest of the way, and then I'll show you how to count, and we'll be done. All right, if this is a 30, just watch. Let me show you something here. You ready? If that's a 30, 60, 90 here, we can also do a 30, 60, 90 at the 60. The only difference is the location changes. So there's your x, y. Now we're at 60. Which one's the long leg now?
Why?
Which one's the short leg now? So do I need to redo this? What can I do? Switch them. The 1/2 now is at the x, and the root 3/2 is now at the y. Now, you want to know why I'm as fast as I am. You better listen up. There's 4 things to memorize there. You're crazy if you memorize all 4. Everybody stop writing for a second. Freeze. Listen to me. Memorize one of the 4. I have this one locked away in my memory. I remember sine of 30 is 1/2. Because if I remember sine of 30 is 1/2, I know that one's root 3/2, and then I just flip it when I get to 60. Memorize one of them, and you've got all 4 memorized. Because I know it's a 1/2 or a root 3/2. That's it. That's my only options. 1/2 or root 3/2. Memorize one of them, and you automatically got the other 3 memorized. You see what I'm saying? If I know that the y value at 30, I don't know why, I just did 1/2. I like 1/2 better than root 3/2. If you want to memorize the root 3/2 is the x here, then that's the 1/2, and then flip it there, that's fine. But at the 30, memorize the location of one of these. Then you got the other 4 locked in. Now, I'm going to show you how to count and do it too, but that's pretty useless when you're actually using the unit circle. Because how many of you are going to have time to draw the unit circle every time you do a problem? That is the stupidest thing on planet Earth. No way nobody's drawing the unit circle every time I ask you how to do a problem. You've got to be able to see this in your mind. You got to be able to see it and do it. Okay? So memorize the location of one of these, because I can keep up with one thing. Now, people are asking about the 45. The 45 is easy. And some of you probably remember it from last year, but let me review the rule. Does anybody remember the rule for 45, 45, 90?
Like somebody wrote two.
Yeah, it's a root 2 relationship. So 45, 45, 90. And I'll show you how to flip the rest of this, and some of you probably already remember. Hypotenuse is equal to a leg times root 2. So you have your 45, 45, 90. Now, I love the 45, 45, 90. Because the thing that I know about a 45, 45, 90, when I'm at the 45, what do you know about x and y? They are exactly the same, because the 45, 45, 90 is what kind of a triangle? Equilateral. Yeah, isosceles. Okay? Equilateral, all sides are the same. So it's isosceles. So x and y have to be what? You ain't got to memorize anything here. You just got to know one thing. What is one of them? Because they're both the what? Same. So when I do this, its hypotenuse, which is 1, is equal to a leg. Which leg do you want to go for? Because they're both the same. Okay, x. That sounds good. Root 2. When I divide by root 2, I'm going to get x is equal to 1 over root 2, which simplifies to what? There you go. And if x is root 2 over 2, guess what y is? Beautiful. Now, the thing that I know about a circle is a circle has an infinite number of symmetries. So a circle is symmetric about the x and y axis. Would you agree? So now I can just start flipping. And I think most of you already realize this. This point right here, ready? Ready to flip? Some of you might have already done this. If this point right here is a 30-degree reference, when I come down here, 30-degree reference, those 2 points should match up. So the x and y are going to be exactly the same. The only thing that changes now, which is why I had you write this, everybody look up here now, is what changes? The signs is it. So when I come down here, the x and y are in the same order, but the only thing that's going to change is the y is what? Which means the sign value is going to be negative down here. So root 3 over 2, comma negative 1/2. If I flip that one, when I go to a 45 reference, 45 I love, because you ain't got to keep up with order. It's just root 2 over 2, root 2 over 2. You just got to make the right one negative. Down here, which one's going to be negative? The y. Down here, which one's going to be negative? The y. And then we flip over here. Flip this, 1/2. The 1/2 is still the x. The y is still root 3 over 2, but which one is negative now? So, no.
Wait, oh, x is negative.
X is negative. So, negative root 2 over 2. Now, some of people think, oh, this is so easy, so easy. I had one person screw it up, and guess what? They screwed up the 30 and 60. They didn't get the order right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. They missed today because they screwed up the order in one of them. Okay, so don't screw the order up. Okay, over here, be negative root 3 over 2, 1/2. Down here, 30 away, root 3 over 2 still comes first, 1/2 still comes second, but what happens here? Both negative. 2, negative root 2 over 2. Negative 1/2, negative root 3 over 2. All right, now I'm missing some points here. These last points are the easiest points, but a lot of people just forget to do them. Can anybody tell me how to get the final 4 points just knowing that this is the unit circle? Since the radius is 1, all you got to do is go right 1, up 1, down 1, left 1. If I go right 1, what's the point? 1, 0. If I go up 1, what's the point? 0, 1. If I go down 1, what's the point? 0, negative 1. If I go left 1, what's the point? Now, since I do a unit circle quiz, which is not very practical, but at least helps you try and remember it and construct a way to be able to do this quickly. Because actually drawing the unit circle itself is not very practical. Tomorrow I'm going to teach you the practicality of why we memorize it the way we do. But for a help tomorrow, to make sure you don't mess this up, and I taught Mr. Knutson how to do this last year, so I don't know if he did this or not. I'm assuming he did. But I can teach you something that will guarantee you won't screw the order up tomorrow. And all you got to do is know how to count to 3. If you will start at your 60, and literally start right here at the X and go 1, 2, 3, and then count the 3 backwards. 1, 2, 3. And then if you will just put everything over 2, because everything always goes over 2. And then if you'll put a house on everything except for the ones, because the square root of 1 is what? 1. So the only thing that get houses are the things that are not ones. There it is.
That's cool.
All you gotta do is know how to count to 3, and you got the unit circle memorized. And then you just flip. Now, you still gotta count your angles out. You still gotta count your angles out in degrees and radians, but that'll at least help you so you don't screw it up tomorrow. It's not very practical because I'm not sitting there counting to 3 in my head when I figure out tangent of 11 pi over 6. I'm sitting there thinking 11 tangent 11 pi over 6. I know sine's 1/2, so it's going to be 1/2 divided by root 3 over 2. I know it's going to be negative because it's in quadrant 3, and I know it's going to end up being negative root 3 over 3. Okay? What you're going to learn how to do tomorrow. I will teach you the practicality of knowing the unit circle tomorrow. But I just need you to memorize it first. Then I'll make you unit circle masters tomorrow. Then I'll let you be on the Jedi Council with me. Might even let you be the head. Any questions on unit circle? You get 10 minutes tomorrow is all. And I will time it.
Are you
So it's
just
9 minutes and 45 seconds for one person this morning. They came up right to the end. So you better practice.
Are you just gonna have
Is it
like just
91 seconds?
a piece of paper
45
with the unit circle?
Fastest anybody did it was 3 minutes.